Consider the neural network shown in the figure with the inputs U and V. U and V are the inputs neurons, and the weights over these connections A, B, C, D, and we have one hidden layer with the activation function as ReLU function, one output neuron producing the output Y, and E and F the weights over these connections, where R is the ReLU function. Given that U, V, the value of the inputs and the weights A, B, C, D, E, F all are given with some values. Now the options in this question are: what is the partial derivative of this Y with respect to A, partial derivative of Y with respect to F. These we have to check, and there are four options, and we have to select the correct option from these options, given four options. This is the question in the GATE 2025 for the data science and artificial intelligence paper. Let's try to see what the possible solution for this case is. So we have to find. So before solving this question, we need to understand what this ReLU function is. ReLU function is maxima of 0, x. If we graphically look at this function, this red curve graph is my ReLU function. And if we look at the definition of this ReLU function, so the ReLU function is defined as R of x, which is actually maxima of 0, x, and in a split form I can write it as it is 0 when x is negative, and it is x when x is greater or equal to 0. So this red shaped curve is my ReLU function. For the negative value, it's giving the 0 value, it's returning the value 0, and for positive values, it's giving the output as the same, which is the input. And the slope at this point is 0, and the slope here for the positive case is 1. This is the slope of this function. It changes with the positive and negative case. For the case 0, the slope is not defined, and we don't need to use that here. So this is our ReLU function and its derivative in both left hand and right hand part. We have to find the partial derivative of y del y over del a. A is here, so this is our a, and we also have to find the derivative of del y over del f. So this my f is here. This is my f. So these are the weights over these connections. So in order to find the derivative, we should have the function. So how is y defined? Y is defined as y is coming as ReLU function of e, the output from this neuron, and the output of this neuron, the weighted sum of this and the ReLU over that, and the output of these neurons in the hidden layer comes from the input neurons. So if I write it in a composition form, so my y is the ReLU function of e times e is this times the ReLU function of, again, ReLU function of weighted sum au plus bv plus f times of ReLU function of cu plus dv. Cu plus dv. This is the form of y. So if I make a change of variables a bit here to make the function simpler, I denote this by z1 and this by z2. So what actually I am doing, this aggregate sum, that the input to this neuron is denoted by u z1, and the input to this second neuron in the hidden layer is denoted by Z2. And these two neurons will be producing some output that I denote with H1 and that I denote with H2. So my H1 is ReLU of Z1, H2 is ReLU of Z2, where Z1 is the weighted sum of these inputs AU plus BV, and Z2 is CU plus DV. Okay, so this is our configuration. Now we first try to understand what's happening in the forward pass. So for the forward pass, let's calculate these values. So value of Z1 is AU plus BV. A is 1, U is 2, so this will be 1 into 2, plus B is 1 and V is 3, so this is 5. And what is H1? H1 is the ReLU of Z1, which is ReLU of value 5, which is 5. What about Z2? Z2 will be CU plus DV. CU, this is 1 into U is 2, and D is minus 1, V is 3. So minus 1 into 3, this is minus 1. So H2, which is ReLU of Z2, which is ReLU of minus 1, which is 0. So these are the two values we got. Now our Y, which is, what is our Y? So our Y is the ReLU function of these two. We can write it as ReLU of E times H1 plus F times H2. This will be ReLU of E is 4 times the ReLU of H1. The H1 value is 5 minus F. F is negative 1. So this will be minus 1 times H2 is 0. This will be ReLU of 20, which is 20. So this is the for the forward pass. Now, if we calculate del y over del A, so del y over del A, so we have to reach to this point A from y. So this will be following the path with these nodes. Okay, this will be del y over del h1 and del h1 over del z1, del z1 over del A. So with chain rule we can calculate this. This is how the partial derivatives will flow. So let's calculate this thing first. Del y over del h1, which is del by del h1 of ReLU of E h1 plus F h2. If we calculate this with the help of chain rule, so this will be, E will be coming out E times the derivative of E times h1 plus F times h2. And in the forward pass, at these parameters given, we know that the ReLU function is having the value 20, so its derivative will be 1. So this will be E times 1, which is, and the value of E is 4, so this will be 4. Now this part is calculated. Now let's calculate del h1 over del z1. This will be del over del z1. What is h1? This is ReLU of z1. So this will be, and at z1 the function is taking the value positive value, which means its slope will be 1. So this will be 1. So if we calculate del z1 over del A, this will be del over del A, and the z1 is AU plus BV which is derivative is u, and the u is given us to be 2. So if we use the calculated values, this, and this, and put here in the product, we get, what do we get? We get, from this we get this calculated value to be 4 into 1 into 2, which is 8. So this is your value calculated. Here you can see only A option has the value 8 coming with respect to A. We can discard other 3 options, but for understanding purpose, we will also calculate the partial derivative of y with respect to f. And let's see if it's coming out to be 0. So del f over del, sorry, it should be del y over del f. So we have to calculate from the neural network. You can see we have to calculate the partial derivative of this y with respect to this weight f. So there is just one step back we have to go. If I calculate this value, this will be del over del f of what is y? It's ReLU of E times h1 plus f times h2. With the help of chain rule, we know that h2 will be coming out. h2 times the derivative of ReLU function at the given parameters. Now ReLU was taking the value positive for the given parameters, so this derivative will be 1. And h2 we calculated, h2 was coming out to be 0, so this was 0 into 1, which is 0. So your del y over del f is 0. This is 0, and the first part is 8, and the option A is correct for this question.